Hello, everyone. Can you hear me?
Yes.
I hope you can. Good, thank you. Who was this? Was this reveal thyself? Who said this? Oh, okay. Oh, James?
James, yes.
Thank you, James. Well, we'll see if anyone else joins. Any questions for this second homework assignment week? I guess, we were more than that in the class, but I'd like to start off with some open-ended questions before I go into my spiel, because that's what I'm here for. And if you have a question, I guarantee you there are many, many others who have similar questions. No questions.
Well, my question centers around what our final project is going to be. It's it said 10 pages or so. Is it 10 pages of code, or how big is a page?
That's a really good question, and I'm actually making a video on that as we speak. Can I even step back? I have a little dry erase board there. I could be arrogant enough to do that, but I'm not going to even. I'm going to be a little low tech here. It'll be 10 pages of a written manuscript. Think of it as a research report, like maybe a memorandum. Say you work for a governmental agency. The people higher up won't know code, so the point of it is to translate data into a story. I think it's the most enjoyable part of the course. It's the most useful for so many of you in graduate programs. In addition, it is, I said this last week, and I'll repeat myself. It is what employers are looking for. They will look for your sort of digital footprint for code, and we can talk about places like GitHub, for instance, as a place where you can share your code. But the final project, I hope, serves some purpose to that end. That, in other words, to go back to what I was saying about what if you are thinking about being a data scientist in the private sector in particular, this is what they say. Know the programming languages like Python and R. R is on the list. And know the stats. But most importantly, do something interesting and that you like and that you're passionate about. So, and we're going to help you along the way. The discussion board already is populated with many data sets that are available. I think it can feel a little overwhelming. So that's where you really need to talk to your designated TA for the final project. Otherwise, talk to anyone. The reason I recommend you talk to your designated TA is because that person will be grading your final paper. So I wouldn't want to lead anyone astray, because I want everyone to do well so they can march forward and do great work. But the main point, and we're going to show examples, but the main point is do something interesting, and in a few more weeks, it's good to be thinking about it. But think about it in terms right now. I would say when you're reading the news or you're seeing stats, think about like what am I interested in, and reach out to us, reach out to me. I do this every time. I'm going to do it again. I might even force my office hours because I really would like to have that one-on-one time, because I think that's where I can really help you. And a lot of it's making the 10,000 decisions to actually restrict the number of, so I just want to mute the audio here. But that's where I think it can feel a little overwhelming, and that's where the goal is really just to do less. Less is more. That's actually a good mantra. One of my best friends told me this: restriction is sometimes a good thing. So yeah, so it'll serve the purposes of the course if that's what you need. But I hope you get an education out of it that's useful. That's what I want. I want it to be useful. Yep. So someone had asked about, well, the available data. Is a question I want to ask. I don't want to identify this person. Is this are you asking about the data set for this week's homework? Because that's in the homework assignment sheet. You go halfway down into part 2, and that's where we provide you with the R data file. It's a tabular data file, a fancy way of saying an Excel sheet, and we provide you with the code. Are you asking about that? Giselle, I'll just say your name if you don't mind. Or are you asking, oh, for the final project, okay. That's on the discussion board. It's actually pinned to the discussion board. You go to the course websites, and you'll see that list there. That being said, as I've done in previous years, I will provide you with a list of and I'm compiling it today as we speak, of data sources to use. Because there are a lot of data sets that are also built within the R environment that are really, really cool. Some of them we use for class, like the Titanic data set. Some of them are just really interesting, and I think a really good example of how you can use data sets without even ever having to do maybe some more of the complex data management stuff. You just call it in, and then you have, I think you have some of the oldest data sets, like I think one is the height of French soldiers in 1700. That's really neat. It was or maybe Italian soldiers. So you can even explore the history of statistics, which for me is really exciting. There's a great book called The Lady Tasting Tea, for example, where R.A. Fisher does some, well, the book is sort of a narrative account, but there's a famous data set where R.A. Fisher, one of the founders of statistics, really modern statistics, basically wanted to see if this woman was able to distinguish between, I think, different kinds of tea or tea leaves or something. Anyway, that's a very classic data set. You can look at that. And you can even look at some other data sets in the class. That being said, if you have any questions, talk to me. Please, please, please talk to me. Yes. So the list of data sets that are available are actually in the World Wide Web. The data sets within R are actually a little bit different. And I'll definitely show you guys that. But I can even, we'll bracket that for later. We don't need to concern ourselves with that. And it's okay to be new with R. And in fact, I welcome feedback. Send me an email if there's a particular aspect of R that you really want covered. Because that's my service to you. But for now, I think the best approach, especially when you're new to R, is get your feet wet. And I'm gonna repeat myself in case you didn't hear this last week. If you want to learn how to swim, you read a book about swimming. Well, you could, or maybe you get a coach and you actually swim. And I think that's really a lot of programming and coding. And even with statistics, honestly enough, I remember the first time I ran into, introductory statistics, and I remember poring over this stuff, trying to figure everything out. And I was so confused. And at a certain point, you just kind of get used to it. That's all. That's the best explanation I can give about that. But with coding, we give you everything you need to solve the problem set. But I hope you can also use it as a chance to dig around, muck around, and explore on your own. And in fact, if we have some time, I'll give you a few minutes to do that. I would ask those of you who are joining, if you could simply mute when you enter. Feel free to talk or chime in at any time. I just don't want background sounds. And I'm sure you don't want that either. Okay. So I will take us through problem for quantitative analysis, if that's okay, using the next week's problem set on popular kids. We all want to be popular in high school, right? Or maybe not. Some of us were above the fray. Okay, so ready to begin? Okay, good. Just like a little quick technological question. Do you see my face? Am I in the picture? Okay, thank you. All right, I just didn't want anyone to be staring at a black screen here. All right. Let's go to speaker view. I'm gonna open us up into RStudio, and I should add, if at this point you are still having difficulty with R and RStudio, please, please, please come to me. I've been fielding questions, but I don't want anyone left behind at this point. Here, I'm just clicking on the icon for RStudio. I thought it was. Hold on for a second. Okay. So I'm going to show you what the screen looks like when you just open up RStudio. And this is important. I'll tell you why. So I'm going to do a new share, and I'll show you what we have here. Here's our increasingly familiar RStudio screen. You can see this. Well, golly gee, I have problem set number 1 here, and I have a Titanic data set. Well, what did I do? Well, I analyzed the Titanic data, and then I close it. So for a lot of statistics packages that you might be familiar with, say Stata, R, SAS, I'm not sure about Excel, not that kind of person. But for a lot of standard statistical packages, you don't have to know what they are. MATLAB, I believe. These are very common. When you close the program, it'll ask you to save the data set, and it'll close the data set. Well, what happens with RStudio, it's kind of like pausing a streaming video, Netflix or something like that, right? You close Netflix, you're tired, you close it, and then you're not really sure what happened in Game of Thrones, not Game of Thrones, what's on Netflix that everyone likes. I don't even know, Breaking Bad, we'll say. And then you open it up and it'll commence at this point where you stopped. That's essentially what is happening here. So I was a little deceitful when I started off. I said, oh, well, either there is kind of a few kinds of files in the R world, we could say. There's the .r syntax file. Syntax meaning that's the code, that's the recipe. Then there's the .r data file, and that is basically the spreadsheet. That's the information. I think of this as the ingredient, these as the set ensemble of ingredients, and this is the recipe for you to cook your beautiful culinary statistical creation. I know for programmers out there, this is super elementary, but I think it's, you know, we all have different places and we all have different things to learn. That's just a simple analogy. Now, there are other kinds of R files. I want to point you toward, if we click on files here and we go to our current place, well, it looks like there's something here called .RData. Not sure what that is. Looks like maybe it was open last time I opened it. I'm not sure. But I believe, I'm not sure because I don't even use it. I believe it's a file, a data file that is in, well, let's open it up. And well, see, that's just nothing. I think that's just a temporary file when you autosave. I'm not 100% certain. Anyway, I'm going to detach that. So when you load something, you can also detach it. I'm just using the syntax here. If you're familiar with Python or even SPSS, you'll see that RStudio is a great interface. We call it a wrapper because you have base R, which is like the nitty-gritty stuff. And then you have this nice wrapper that makes things look nice and shiny. And it actually helps you out. One of those features is autocomplete. So I'm just actually cutting and pasting this. Oh, I can't. I don't know. Well, I will. Don't worry about it. It's no big deal. I'll detach it this way. You can just. Oh, it's nothing. Anyway, the point I really want to talk about is this thing called an R history file. Capital R, lowercase for the rest, right? In programming, we call that camel case often. Why? Because a camel has a hump, right? You can say, my name is Nay, and And that's important for naming variables, what we call objects, which object is anything really, for data sets, that kind of stuff. Just keep that in mind. I've said that before, but that's a big kind of a common bug that all of us run into now and again. But the point I want to make is when you reopen R after closing it, you have a history here. And this is useful because nobody has a perfect memory, but look at this. Here we see all of the syntax that we did for last week. Oh, you see I did some other funny stuff here too. But yeah, you can see I did some other really cool stuff too. But the main point I want to make is that the history file there is a record of essentially what you're doing. Ideally, and if you're this is just an aside for the programmers, if this is like in the margins of a book, you can set your working directory so that all of these all these automatic files, like the history file, and that looks like the temporary data file, that they're all located within the same folder or path file. You can do that, and you do that using a function. I'm sorry, I just there's someone's asking a question. I want to make sure I address your needs. Yeah, you got it. Yep, thank you. Yes, exactly. It's a programming language, so there's a kind of a similar logic going on here. In some ways, if you're a looper like I am, you like to loop things, and here I'm getting a little techie or geeky. R is not very good at that. It's called, and we'll talk about that later, it's slow. Python is good for looping. R is not very good for looping. That's just FYI. It's a good example of how I think the software or the language that you use shapes the way that you think, as well as you influence. I don't know. I think it's a good example of the sort of dialectic between man and machine, in a sense. Man in the non-gendered sense, mankind. But yeah, it's just like Bash. It's like a lot of other things. Yeah, so you can type present working directory. I thought, or maybe current working directory. No. Maybe I have to put print. Let's see. Well, maybe it isn't. I don't know. I thought you could use that. It's, yeah, someone is asking, Walter, is it like pandas in Python? So Python is, for data science, Python is the other programming language that we want to learn. I was going to post this to the discussion board, but I don't want people to get nervous about the languages that they learn. But the big question is R or Python? Those are the two programming languages that I will commit to teaching you guys. R is great. The other one you're going to hear is Python. I think increasingly Python's popular, but I would, and I'm sorry for the disquisition if that's not useful for you, but I think for so many of you, this is going to be part of our cultural capital, just to know what Python is. It should be on your radar. Python and R are the two major programming languages that are used by the Google data science, a lot of data scientists. In addition to everything else, of course, you have to learn everything else. But for data analysis, Python is increasingly popular. I like Python. And someone had asked, is it like pandas in Python? Well, Python is very similar because it has libraries, I guess you could say. And pandas is the name of a library, for instance. The reason we stick with R in this course is that it is actually, I think, for now, better for statistics. If there's a stats model, a stats technique that is avant-garde, then it'll be in R probably, because it has been used by statisticians. You go to a stats department, it's typically what statisticians will use. And increasingly political scientists and sociologists and psychologists, it's finally trickling down. So there you go. That's if you want to have like a general sort of stereotype. I think of, what did I say? Statisticians will use R. Computer scientists will use Python, or astronomers. Neuroscientists use MATLAB. I'm going to continue with this. Psychologists use SPSS. Business people use SAS. And economists will use Stata. There you go. And everyone else in the real world uses Excel. And I've used Excel. So no shame in that game. Okay. That's right. Someone had asked, we try to avoid looping. I don't want to get too involved in this, but looping is in essence saying, well, gosh, if I have to do something 10 times, can't I just say, tell the computer to do the same thing 10 times, run the racetrack 10 times, rather than having to write the code 10 times? So yeah, you can loop in R, but we want to try to avoid that because it's what is called a vectorized language. Vectorized, I can't even use the rest of it, but basically it deals with vectors. And that's really just a speed issue. Otherwise it's slow. That's the main point. Looping I find to be more intuitive, but yeah. Just keep that in mind. It's a different way of thinking. It's okay though. It's good to learn. So yeah, we use data frames and we do use some matrix someone is asking, Walter, do we use data frames? Again, I'd never really explained this. You'll hear data frames a lot. That is just a data set, okay? And when I say tabular data set, I'm being quite specific here. I'm saying a spreadsheet, basically. Something you can view in Excel. So tabular data sets, data frames. I like the term data frame. It's what you're going to hear in R all the time. It's also in a job interview. If you signal to your potential employer that you're familiar with the language, it's kind of like a secret handshake. Oh yeah, data frames and matrix operations. Yeah, I know what a data frame is. So think of data sets as data frames. Broadly speaking, though, data frame is kind of within the R world, quite common. Okay. So other questions. I'd say I wanted to get us here because this is going to be a problem for you. There's a concept that I want all of you to be familiar with. Data hygiene. We don't want to make mistakes. That's terrific. That's awful. So how do we make sure that we don't have mistakes? Well, we want to make sure that basically, I was a Boy Scout. We want to make sure that we leave our campsite clean. Okay, we did our Titanic stuff. We're done with it. We don't want to muck around with it. And if computers are very literal, if we tell it to do something, it'll look for something that might have the same name. It might have the same path file. And that can cause us problems down the road because if we don't know what is in our environment or our workspace. And an environment, you could just sort of think about it as your sandbox. That's the way I like to think about it. Put all your stuff in the sandbox and then play around with it. Well, sometimes you just want to take everything. You have to take everything out of your sandbox, and that's what you have to do each week for data hygiene purposes. Because we're not analyzing the Titanic, we want to make sure that we're never going to make that mistake. So I'll show you just through this just to make sure that you're not going to commit that problem. And I know I may be belaboring this point, but the reason I'm saying this is simply because this happens a lot. Okay, first thing to do, look at that little broom there. Oh, clear objects from the workspace. That's what you want to do. That's the first thing I often do. It'll ask, do you want to clear everything else? Yeah, so we're just doing a little bit of a house cleaning. Okay. You might want to even look at packages. Maybe there are not packages here, but that's not really relevant. Files is probably most important for you. You can see kind of, I have these things here, but I'm actually going to use the drop-down menu to pull in the new script and pull in the new data set. So before I do that, I want to just basically close this off right here. And then I'm going to close this off here. And then if you go to the, I don't know if you can see the drop-down menu, but at least on my Macintosh computer, you can actually see, let's see if we can do it here. Well, I don't know if you can. No, okay. If you go up to the upper left-hand corner, you should be able to do, you should see a bunch of drop-down menus. One of them is including file, and you can basically do a new file or open file. And we're gonna do, we're just gonna, well, we'll open a new file. That being said, see, I've been using a PC for such a long time. I use a keyboard shortcut. You can clear this workspace here, but it's not necessary. In other words, even though I cleared everything else, the fact that I typed a bunch of gobbledygook here, I could even type, you know, print. I don't know if it's hello world. Hello world. No, they don't even do that. Okay. Well, anyway, the main point I want to make here is that you can type whatever you want here. This doesn't matter, because as long as you have this little caret here, this little prompt and a blinking cursor, you're okay. If you don't, which sometimes happens if you run a code halfway through, then your console is not ready. It's not clear. So things can look kind of messy with a console, as long as you clear your environment. And yeah, as long as you clear your environment and you close your scripts from the previous weeks, you're okay. History files, if you want to worry about it, you can. Otherwise, don't worry about it. Okay. I want to show you, because this is also an issue, how to make sure that your console has this little blinking cursor, because we want it, the console to be ready. It's like DOS, you know. This is old school. You know, if you kind of think of that blinking cursor is like, okay, she's ready to do whatever you would like. I'm not sure why I assigned a gender there, but you know, let's just say I'm gonna assign something object, hello world, and you'll see. Well, why isn't that working? Okay, there you go. I had to put in quotes because it's text. You'll see. What I did is I just defined an object, foo, you could say. The letter A, I now defined as a sentence, hello world. Now when I can type the letter A in the console, I can type hello world. Okay, well, that's really not that consequential. But if I did something like A, and then I did this, and then I did not do the close parenthesis, and I say ran half of the script, there's a little plus sign there. Now this is more common when you're writing functions, or you're doing loops, or you're doing more interesting complex stuff. This is also interesting though. You don't want that. You don't want that. And I'm going to press carriage return forever, and it is not ready to rock and roll. It's saying, what now? What do you do? Well, you could finish the code or type escape. Now we're back at square one. We're ready to roll. So that happens if you're running a function or a code that is incomplete, right? It's like if I stop mid-sentence and I am going to say something, and then you want me to say something else. Okay, so that's data hygiene 101. Basically the bare essentials. There's a lot more in data hygiene about reproducibility, but that's what I really want you to do. Clean slate each week, tabula rasa. So now I'm just going to open the file. And as I open the file, do you have any questions so far about what I've done, or just any other questions about RStudio in particular? Okay. Okay, thank you. Yeah. Yeah? I'm sorry, was there a question in there? Hello? Uh-oh, I'm sorry, I didn't hear you. Hello? Okay. Okay. So here I am. I'm just going to open the PoplarKids.RData set. So I actually have my stuff saved to the cloud, not to my desktop. So I'm actually opening it from somewhere else. But you'll see I have it open. And then, so there's that code. And I just did the drop down menu. You could also navigate through here, but it's just too, it's not very interesting. It's not on my for me, it's not on my desktop. I recommend putting it on your desktop because it's a great reminder to do the homework. That's what I always do. If I have something that's pressing, I have it on the desktop. Another aspect of data hygiene, each project and each analysis, I work on many different projects. I have many different consulting projects. Each tub own bucket, I will have a designated location, path file, place, whether it's in the cloud, whether it's online, for each project. Don't mix your apples and oranges. It's a recipe for disaster. Okay, so look at this. Here I just did the drop-down menu. So what would you do in the class assignments? If you haven't already downloaded that, you create the new folder, put it in a desktop, something like that. Give the folder a name that makes sense, that's short, that doesn't have any spaces, I would say, like pset1 or pset2 rather. And then drag and drop, or take your downloads folder and put in that folder the data set and the script. Easy, right? This is where we should be. Now, what's the only thing that we should maybe be concerned about at this point? Well, we got this hello world thing in here. Oh gosh, well that's kind of a pain. It's pretty inconsequential, but I don't like to have a workspace where I don't really know what's in it. So I just removed it. I didn't have to put the quotes there, but a good function to know if you just want to remove an item by an item. I'm sorry, I have my Mac mail open. I'll close that. This is life. Removing objects hand by hand is useful. Now, of course, now there's no object like that. Remember, I called this little thing, it's just a caret and then just a dash. It's not a dash, it's a hyphen, excuse me. So that I guess you could say it's a greater than sign, less than sign. I'm just dyslexic, I don't even know. It's an arrow and a little thing there. It's called the assignment operator. In R, we call it the assignment operator. To the left of that is what we're defining, and then to the right of it is the definition, right? So it's sort of like, Earth. Well, what's the definition of Earth? A planet. Okay, see, so you'll see lots of complaining here. So, look. I've been doing this for 10, 15 years. I don't even know. I've been coding forever. And look how many mistakes I'm making. Why? Well, because there is kind of a similarity between different coding languages, but there are also some differences. And so if you're programming or using one language in one instance, you might have some difficulty switching into another. And so in my case, I was using something that for work with an economist. But what this also, I hope, illustrates is as you get familiar with it, you'll see that it's kind of like if you ever learn a Latin language. Spanish is similar to French, which is similar to Portuguese, which is similar to Italian, and Latin, which are all similar to Latin. A lot of programming languages, object-oriented programming languages, that is, languages that have enable you to define anything under the sun, pun intended, right? I can define, and we'll talk about that later, but just be familiar, this is an object-oriented programming language. And I'm sorry, I interrupted myself. The main point is there's a lot of similarities and that you can draw from if you know other kinds of programming languages. There is some build up there. I don't even know how it gets to a certain point. You just kind of intuit it. Anyway. Okay. So all that's to say is that there's a good reason you're learning this, even though it's maybe not as intuitive as others, because it'll help you. Okay. So what do we do first, class? We got the script, we got the data set. What do we want to do? What's our first concern? Once we did everything I said. Can anyone text an answer? I hope I'm not putting you on the spot. What do we need to do first? Walter has a really good answer. Make sure data set is an object space. Absolutely. And that is a big concern. So yeah, sure, why not? Let's do that. Let's make sure we have that here, and keep in mind, as the more we get into R, we'll learn there are different kinds of objects. They're data frames. We know that there are some objects called data frames because here we have one called data. There are also other ones that are just called values. See how I have two objects now? One is called values, one is called data. A data means that it is a data frame. And remember when I said to you last week, a data frame is quite particular. It has as columns variable names, and it has rows observations. That's pretty standard. Here's what R does not have, as opposed to so many other standard stats packages. So if you're working in SAS, for instance, which is very common in business, maybe you've had that experience, variables will have labels. Well, here's the rub with R that might be vexing for many of you. And by the way, if you're not familiar with like a label for a variable, it just simply means, I don't know what, let's say location here. I'm not really sure what location would mean here. But if you open another stats package, you will actually see that there'll be more information available attached to the variable. R doesn't provide us that. It's too cool for that. That's where you have to go to code books or PDFs or descriptions of it. So one kind of, I think, sometimes annoying thing you have to do is you have to switch back between, by the way, I'm going to interrupt myself. With R, there's always a way to do things. And someone did answer yes. With R, there's always many ways to do things, so that you can, I know you can assign labels, but most of the time you can't. So when you're doing your analysis, you have to flip between this, and then you have to flip between the PDF that describes what the variables are, just to make sure you know what it is and what the values are, because none of that is built into the data. Well, that's kind of vexing. In class, our version of the code book is our description of the data set, what it means, what these values mean. So just I want to just throw that out there. That is a disadvantage with R, I think. Also sometimes crashes when data sets are large, but who knows? But there are plenty of advantages. So we have the data set here, but that's not exactly what I was looking for, because my question referred to the fact that, well, once we have the data set in, what's our concern with the code? And that's exactly it. First thing in your mind once you see script, you have, if you use anything else like a LaTeX, there's something called a preamble. You know, the Constitution has a preamble. What does that mean? It's a highfalutin word. What do you need to do before you do things? Well, in R, you need to make sure that you have the library that you need to do the analysis, because not everything is built into R. And the cool stuff is definitely not built into R. They're written by other people for free, and you have to load them. Now, you only have to install packages once. However, I'm paranoid. I like to install packages every time. But I first want to show you that because we installed Mosaic before, we don't have to do it again. So remember, install packages, it means you put on your machine and it's installed. Library means it's sort of like, okay, I have a book on my shelf, now I want to pick it up. Good timing. This is kind of what the library function is. I know it's a little misleading because a library is a bunch of books, but that's the kind of the best way. If If any of you can think of better analogies, please help, but that's the way I think about it. So installing means I bought the book at the Coop, Harvard Coop, or probably not. And then library means, oh, okay, I got to sit down and do work. Let me pick up the book so I can actually use it. Okay, so let's run it. And there we are. We should be fine. And we can double check this. Remember, if you go to the Packages tab right here, typically you're on Files, go to the Packages tab, type in what you're looking for, Mosaic. It's there, it's listed. And if it's listed, that means it is installed. If it is checked, if it has a checkbox there, it means that we have it in our hands now. So there you go. And later we'll talk about how to find other packages. But if you're really curious, the Help tab is a great place to start. I'm sorry, the tab, great place to start. Okay, but let's go to our Packages tab just so we can, I don't know, make life simple. Oh, actually, I'm sorry, let's go to the plots because that's where we're going to see the output. So remember, the plots is outputs. The console is where we're going to print out the numbers. Okay, we did it. But I'm going to be paranoid. I'm going to run them both again. It's going to ask, do you want to restart it? One or more are currently loaded, restarting, blah, blah, blah. Yeah, go ahead and restart it. It's fine. Notice by restarting R, you see this little thing here. This reminds me of the, I'm revealing my age. It reminds me of the olden days when we used to have games that were just text-based. Zork, for instance, or Myst, if you've ever played that. So, you know, you have to type in things. There's this ominous ... but that's it. And if you notice, the installation of the packages is far shorter the second time around. So, and I'm going to be a little persnickety here, Jesslets. I hope I'm saying your name correct. Or is it, I'm sorry, Sam, is it Sam Jesslets? Okay. In any case, we don't want to say load Mosaic. Yeah, okay, Jesslets. C'est un bel nom. I speak a little French once in a while. It's a very beautiful name. Now, we don't want to load Mosaic. We want to install Mosaic. Bienvenue. To be honest, the name escapes me for the library function because I don't talk about these things a lot of the time. But when we say load is an actual function. So this is kind of why other people are frustrated with R. Sometimes you can't define objects with certain things because those are actual functions. And I'll show this to you. One way to seek help is just put a little question mark in front of what you might be a package. Reload save data sets. So there is a kind of a nomenclature there. I think it's a little elitist. I don't think it's necessary. But that's okay. We're breaking down walls here. Okay? This should be for everybody. But keep in mind, when you're loading a data set, you're putting it into your work. I guess you're loading it. I see I'm even losing the word that I would normally use if I were speaking in lay terms. For library function, we didn't even look at this. Put a question mark in front of something. Oh, look at this. It's so helpful. Notice that it says library and require load. Okay, you know what? You can load packages. I am sorry. See, that's the confusing part. Load is an actual function. So, but you can say you're going to load libraries too. I would actually say attaching packages. That's right. You're kind of glomming it onto you, like a, you know, right here. You're attaching it to things, because the converse of that is to detach packages. You can remove packages. And I'll show that to you. Oh, look at this. I restarted the installation and I forgot to load the library. So keep that in mind. If you're going to reinstall something, you're going to have to load the packages or attach the packages. So notice I did it here, but just by clicking on that little blue button. And that's the great thing about R. Think about it this way. There are 3 ways to do things. Console. If you're a hardcore programmer and you like to type, do that. If you want to just point and click here, you can do that. And that goes for most things in R Studio. Or if you want to upload packages, I think you can even do it with a drop-down menu, but it's, well, maybe not. I don't know. Maybe you can, but I certainly don't do that. But anyway, there are multiple ways to do something. Okay, so there we go. We have them installed. We have that confirmed because we see them listed right here. Okay. I think we've kind of belabored this point, but if you notice, if you read this red text here, they do call it attaching a package here. And this is kind of worthwhile just to read. This is pronounced dplyr. There is no third way. I was confused. I was wrong. There probably is a third way given that it's R. It's pretty flexible. I was thinking about uploading data sets and seeking help. Those follow the rule of 3. There should be though, right? It seems like 3 is the magical number. Yeah, well, thanking me because I report application because I didn't clear in the first place. But the point is, yeah, I would like to think attaching packages is probably the better way of speaking here. It looks like my internet connection might be a little iffy. If so, please let me know. I'm going to mute my, so I'm going to hide my video. I'm going to hide myself just so that I can make sure that we can continue. If we still have internet problems, please let me know. Okay. So I wanted to point you towards something called the dplyr package. It's dplyr. You're going to know it in the future. Okay. Okay. I'm sorry the connection is skipping. If so, at least we'll show you how things work. And I am sorry for this. This is I'm not sure why. In any case. Okay, yeah, I thought so too. I'm also just trying to decrease the strain on my computer. Also, I know when there are a lot of people who are online and they all have their video streaming too, that could be an issue. So I know everyone muted, but if you can disable yours, that might also facilitate this. Okay, let's get back to X. So it's sometimes useful to look at some of the stuff. Packages that are required, you're going to see these time and time again if you're ever going to use R. Oh, okay, thank you so much. Like that, I'm going to just do that, and that should work. Am I still there? Now, hear me. Can you hear me now? Mike, you should be able to hear me. You should hear me now. Works. Oh, is it low quality? Okay. Shoot. All right. Sit tight. We're going to have a 1-minute break, and I will return with an Ethernet cable. I apologize for this. This shouldn't be happening. Okay, I should be back in the meeting. Can you hear me now? Okay, good. All right. So that was a brief interruption. Thank you, guys. Okay, good. So read some of this stuff if you're really interested. If you are going to pursue any kind of career related to science, to data analysis, because all of these required packages listed here, ggplot, lattice, you're going to use them. dplyr, yes. Okay, but the main point is everything seems to be going well. Everything seems to be okay. So now we're good to go, and now we're finally at square one. Well, gosh, I spent most of my time talking about cleaning up the workspace, or answering questions about the final project and explaining its importance. Clearing the workspace, so that way each week you have a clear workspace. And then showing you how to basically get started. So that your goal should be to have your RStudio look like this. And this will help you, this will permit you to answer the second half of the problem set. It's a lot of work to get here now, but the only reason I'm emphasizing it now is because it's going to be the same procedure week in and week out. Once you're here, it is smooth sailing. You won't have to even think or do anything like that. We give you the answers basically pre-made because we really want to emphasize concepts. So I'm going to just go all the way to the bottom, and I think I'm going to run this script. And look at this. I also want to show you, if you hover over things, you can see what they mean. So that's also useful for just sort of natively figuring things out. But you just want to run. Well, look at this. We have a lot of stuff here. So as you see, we can scroll up, or we can actually make this larger. Press that little large button. Here's all the gobbledygook I had before. In the console, the comments are one color, and then the output is another color. And here we provide you with the answers. So let's go to the top. Oh no, look at this. Well, this is more interesting than I thought it would be. It looks like we have an error here, because we have 3 data sets loaded, and it looks like it's giving us an error message here. It looks like a sparse vector, and then it's not finding the particular variables. Well, this is probably my arrogance, is my confidence in thinking that you can just run code to sweet without any error. That's normally not how I roll, but I was being a little arrogant here. But this is also a good example to show you how to clear all the plots. Again, look for that little broom, clear those plots, because that's junk. There might be an error when running the file all at one time. That shouldn't be the case, actually. You should be able to just run everything. To be clear, the broom, if you look at the panels here, right, this is like these are 4 pinned panels. Look for the little broom at the top, right here. Here it's like kind of faded because everything's clear. Here it is. Hover over it if you don't know what it is. And you can see my hand is a little bit too large. Clear objects from the workspace. And I kind of like workspace a little bit better than environments. It's maybe just because it's a little more democratic, but workspace environments. And that's very important because there are a lot of objects in your workspace or in your environment that are essentially, you may not even see them here. Okay, history 2. Let's clear our history. We can do that for history. That's really nothing except maybe if you just made a bunch of mistakes, you don't want that in our virtual stenographer. We don't want that on the record. I'm going to close this because this was a part of the view function of one of the data sets. Let's go to the environment, and notice I cleared the global environment. Global environment meaning this is the world in which we inhabit. And I'm going to go, I think what happened is I might have opened the data. Okay. I did some things. We are creating other data sets that basically overread some other parts of the code. That was me running code without remembering that we're going to create some data sets here just for illustrative purposes. Okay, we're subsetting. So that's, again, the danger, I think, of running code. Normally, I don't do that, to be honest, unless I've debugged it. I would usually just highlight each question. But here we go again. We're going to open the file, open the data file. So we go to our, wherever your home directory is, and we're going to open it up. So, sorry for that error. Actually, I'm not sorry for the error, because everyone will make mistakes. And I think that is how you learn. And the best researchers, the best statisticians are those who learn, who commit enough mistakes when it's not consequential that they can know what to do when there are real problems. Okay, we don't want to open the text because it's inevitable that you'll run into coding problems. It is just going to happen. I'm sorry. Okay, we open the data set here. It has 478 observations, 10 variables. If we're really paranoid, we could even just say we're just gonna, I'll type in the console, popular kids, and I should press tab and it'll finish it. And there it is. Those are the variables that we have here. Someone is asking, Amanda is asking, go question by question. Yes, I would, because A, it helps you understand things. Second of all, it's kind of like the difference between speed reading a book and actually reading a book chapter by chapter. Otherwise, you might even get your output mixed up, right? You don't want that to happen. Those of you who are using a PC, if you could remind me how to clear the console. This is actually bothering me. I just got it. I'm new to Macs, and I use, at some point with R, oh shoot. At some point with R, you use so many keyboard shortcuts that, I just minimized it, that when you switch to a Mac, when you use a PC and you switch to a Mac, you don't know what to do because the command key doesn't work. But the point is, there is a way to clear this stuff here. I did Control L, yep. That's what I thought. So I'm doing Command L. So that's a great keyboard shortcut. If you're like me and I get overwhelmed. Maybe it's my sensory issue, but I actually don't like to see too much gobbledygook. There we go. Okay, so it is Control L on a Mac. Okay, look at this. Okay, everyone's a beginner at some point, and that's also true with a lot of stats projects. So Control L, beautiful. I like this. It's really inconsequential, except for me, I like to start anew. But otherwise, it's inconsequential. And if you can tolerate a chaotic environment, that's okay. Okay, so the first question here, we're going to look at the average of 4 qualities. We're going to look at the mean here. The mean is a measure of central tendency. It's the average in lay terms. And here I'm running into more errors. Okay, let's just see. Object looks not found. And there's the object looks. Okay, well, this is unusual to me. I actually have not seen this. And so this is my concern. Remember I talk about installing R, you have the base R, which is like the bare bones. And then you have what we call the Mosaic package, which also uses the same command. My concern is that we're actually using, something is getting lost in translation. So this is my first thing to do is, well, I want to make sure that we have a Mosaic installed, and we do. Let's just even see if there's something called a mean function. Of course there isn't. Well, that's a little peculiar to me. Now, here's another thing that could be happening. I'm going to go here, and if I just did it, so this is a great example for looking for help. Do the question mark, mean, And for a function, you don't have to type the closed parentheses, I believe. Yeah, you get the same response here. Help topic on mean was found in the following packages. Make sure that you look for the package within the Mosaic library. And then if you double click that, you'll have what is the canonical R help R documentation. Some of it's good, some of it's horrible. I have a video that is 38 minutes long or something like that, but it's useful because it shows you how to get help in so many ways. Now here's the issue. If you have read the introduction to the Student's Guide to R, the developers of Mosaic have even said, yes, we commit mistakes. We have errors too. So it's possible that there was maybe some update to their. Someone's asking if I need an underscore. No, you don't need an underscore. Oh, look at that. That's possible, and that would have been one of these little changes that is quite consequential. Thank you, Amanda. That is very, very astute. So let's try that and look at this. So all I did was do the underscore, and it gives you so much help. So this is the kind of the nice thing about I like about our studio is for slow pokes like me. You can actually see a couple things here. This is information rich. You see what the command should be. You see something within these squiggly brackets. You see that this is the Mosaic package. And then you have the beginnings of the help file. And you can even press F1 for additional help. And the point I want to make here is that in the help file, it'll have that description. And then the second point is the usage. And the usage is how you type it. That's a great question. It looks like mean might here. Mean underscore looks like it's more flexible. That's my guess here. And I'm telling you why. Because keep in mind every function is bound by open and closed parentheses. And within a function, there are, if you think of like a novel, there are also chapters within the novel. Well, the little components of a function, more advanced functions, are separated by commas. And each one of those is called an argument. And notice how many different things there are, we could say, arguments there are in the mean underscore. One thing I'm noticing here is there's this groups function. You're actually saying, are there multiple groups? So I'm guessing you can probably do it by multiple groups. You can also do something with missing values here. Maybe also specifying the data. This is my guess. That being said, I don't know, because this is something that they have changed. But let's just make sure we get this to run. Okay, object grades not found. Okay. So we know that grades are found, and I'll show you why. I'm going to press tab. Remember, you can do the autocomplete, and then I'll highlight this and press, oh shoot. And then I'll just, actually you can just go to the end of the line. Oh no, you can't. Press run. Well, we know there's a variable named grades because there we are here. And that's what that first item does. And we know that's numerical because we can see that right here. We can also see the grades variable here. So let me try something else. Data equals popular kids. I'll just specify this other junk. What I'm a little puzzled by. Aha! That's a great question. Does it require a tilde here? Well, we didn't write it this way, but look at this. Many of these functions mask core R functions to provide an additional formula interface. Old behavior should be unchanged. So this is why I was confused about, or not confused, this is why my first instinct was to think there's some wires crossed. Remember, we have the same thing that is in the old school base R. It's like the foundation. And then we have this tilde formation that should be pedagogically useful. That might be an issue. So let's put a, so yeah, now I'm even forgetting where we put the tilde in tally. mea culpa. So, by the way, if you want to just see an example, go to the bottom and look at examples. Okay, so the tilde is always before the first variable. They also wrote the syntax quite well, actually, but that's for later points. So let's try that. Thank you so much. Who said this, by the way? Yeah, just let. Thank you so much. This is my hunch, right? Because maybe they decided that, okay, we should really mandate this. There we go. Voila. Now I'm going to try to get rid of this underscore because I hope that they haven't changed too much. Yep. Okay, look at this. Good. So it used to be, not too long ago, that you could just finagle your way without using that tilde function. But they're actually sort of being persnickety here and saying, all right, well, we're going to make you do the tilde here. That's good for all of us. So just keep that in mind. Now, I know we've asked this on the discussion board. Are you all familiar with what the tilde does, what it means in this context? Now we could even just go to the help thing. Where was the tilde? Well, anyway. Yeah, so the tilde is sort of like an equal sign in the workhorse of stats, which is the scatter plot. See, I was going to actually break out my little dry erase board when I was going to talk about final papers, but I'll break it out here because I don't like drawing on a computer screen. If I can grab it. Okay. Now I'm gonna turn on my video. All right, so there we are. And you'll see how bad my handwriting is. Keep in mind that often when we're talking about, if you remember algebra and you want to know like a linear line, we do y equals mx plus b. If this does not sound familiar, that's okay. But typically we have, say, here's an x-axis and a y-axis. I'll show you. And then we have rise over run. Right, this is sort of like the basic, if you can read this, I don't know how bad my handwriting is, but right, if we have like just a linear plot of something on an x and y axis, we'll have the rise over the run, and we can define the line on the Cartesian plane, you could say, if you want to be fancy, or on the x and y coordinates, basically knowing what the value of the line is when y equals 0, so this value here, and what the slope is, which is the rise over run. So in other words, as long as we know b, which is what is the value of the line when x equals 0, in other words, and what's the starting point, and what's the slope, which is m, then you can take any value and figure out what value of x, for example, and figure out what would be on the value of y. If that sounds familiar for you, I'm glad. If it doesn't, don't worry about it. But this is like I think you probably would have learned it in high school algebra, so don't worry about it. But y equals mx plus b. But the main point is there's a big equal sign here. You're evaluating everything, and you want to figure something out. You put a bunch of inputs, you know, okay, I know what x is. So if I know what x is on here, let's say this is a 4, what's the value on my line? Well, that's a lot of statistics is based on that. It's essentially, we have an independent variable or predictor variables, and we want to know what the outcome is. That's why we use the tilde. It's in the R language, because we use equal signs for other reasons, and because equal signs go both ways. The tilde is actually directional in a way. It reads from left to right. The outcome, y, is what we're trying to figure out. It's a big question mark. And then the rest is everything that we're putting in. And that's the way to think about the stuff that you're putting in the console, really. is you're basically saying, what I want to know is everything after the tilde. So that's why it's a useful kind of way of framing, of thinking about the syntax. This is the reason I'm emphasizing this as a style of thought, is because that's what I think is the intent, but it's also a way for you to think about what you're doing. The console isn't just plotting stuff here. It's actually creating output. So that are the result of something. So if you're a verbal person like I am, then you can translate this into a sentence, right? You can say, and I'm going to use the assignment operator. Where the assignment operator just says I'm going to label something with any thing. So I'm going to do question 1, answer. I'm going to assign it as this. It is the mean function where I take grades using the data set PoplarKids. Now look what happens when I combine it with the assignment function. And I'm using the assignment function to illustrate the fact that we don't have to even use the console. The console prints it out for our convenience, but we're creating outputs. And this is what makes R and programming so useful. You can create new things, new objects as answers. But let me run this and I'll show you. Our environment looks so confusing. Oh, look at this. We got Q1 ants. Whoa. Right? So there's the answer to Q1. Well, no longer do we have to deal with the pesky, scrolling around here. We got this right here. Okay, Q1. Great. And that's just by using the assignment operator. I know the assignment operator is new. It's a little strange for many of you. Don't worry about it. It's not necessary. And again, I have another video for that. I just don't want to bombard you with 10 hours of video in 1 week because we have to pace ourselves, and there's some more important things. Okay. Variable assignments. Yes. Well, so yeah, I think if you're using other kind of language, we can call this a variable, like in SQL, I believe. I'm not sure. Again, this is where language is kind of persnickety or important, because a variable in statistics, in R in particular, refers to those columns right there. Those are the variables, and that's when you read a stats book, that's what they're going to mean when they mean variables. So this is the sort of the worlds of programmers and statisticians, right? And even statisticians will use different formula. It's not as standardized as we'd like. So yeah, you could call it variable assignments, right? All you're doing is you're taking an arbitrary foo, and you're saying, I'm going to call it this, because now it's something I can play with. It's an object now. What do you want to do? You want to round it, for example. This is the great thing about this, is you can round it. So I just here I have the object. I'm going to do a comma here, and I think you can just round it to 2 decimal places. I'll just do 2. And here it is. I mistyped it. And there you go. It prints it out to 2 decimal places. There you go. So that being said, don't round, don't deal with that. And the reason is that rounding is an issue when you have, precision is not important for the final answer, but if you're rounding in your mid steps, you can propagate errors interminably forever. See, I can't even, you say statistics and then you say R enough, it's really straining on your tongue, because I've been in Boston too long, and this city is not, does not have a strong affinity for the letter R. Okay, so I hope those aren't, I think what I'm saying right now is useful. Even if you think, okay, it doesn't help me with the assignment, go ahead, run the script, put the tildes in, you'll get the answers. But I think there's more to education than that. So we know what the mean is, we know what an average is. That should be kind of intuitive. I want to point out, though, that might be a little less intuitive. What are these categorical variables? You have like the gold medalist, you got the silver medalist. They're four categories, right? Because these are popularities, right? And then you got the bronze medalist, and then if you're 4, then you're not medaled. Can anyone explain why these variables right here are actually numeric? Why aren't they categorical? I mean, last week we talked about, age. Yeah, age is a number. Money, yep, certainly that's a number. It's a number a lot of people care about. Well, maybe is that, well, we can think about that. That's an interesting idea. Well, we don't have that example here. But what if I had, like, say, gender, and instead of gender for girl, I said, okay, I'm going to call girls 1s and I'm going to call boys 2. Does that mean I just turn gender into a numeric variable?
Hey, Dr. Fossey, this is Walter. So I thought from lecture, one of the definitions was we use categorical so that we could work with the data. So if you have them as strings, you can't really work with them for like mean, mode, and median and other stats that we want.
Yes and no. This is where it gets a little dangerous. You don't want to just make things numerical just so you can work with them. They also have to make sense, right? So this is I'm being a little tricky here, but this is important. A key distinction, because if for so many other stats packages, they will actually have a number assigned to qualitative or to categorical variables. In R, we call them factor variables, and in fact, in R, we do not ever really want to assign a number to a say a binary categorical variable like gender. What we have here for gender, girl and boy, is just fine. The average of randomly assigned numbers to distinguish the two groups would not make sense. Someone else is asking another great question. Are grades categorical or not? I hope I'm not opening a Pandora's box, but what I am pointing out is that numeric variables have a value where the distance is meaningful. So I could call girls 1,000,000 and boys 1. And then all I'm doing is I'm replacing more sensible terms with nonsensible terms. It doesn't make, so logically it doesn't make sense if you have two groups and you're dividing the sample into boys and girls that you would somehow make an average of that. You can tabulate it and you can find out the percentage of the groups, the proportion, but that's categorical data analysis. In numerical data analysis, the mean, the measures of distribution, central tendency and the spread actually have meaning. That's the best way to put it. I'm sort of stumbling my way through talking about this because I see other questions that are also interesting. So to be clear, you can assign numbers to even categorical variables, but they won't make sense. So numerical, a variable is numerical. Quite often, if it's read in correctly, it'll say it's numerical. A factor, remember, is categorical. But numerical is something that not just that you can count, but that you can count, and that's the way it should be. Because often you'll import data, say if you import data from SPSS, which is a common stats package, they'll have numbers that then have labels attached to them, which doesn't make any sense, right? It's just like, why deal with that? So you have boys and girls, that's it. You can analyze that. Numbers are numbers, strings or text are text. So that being said, numbers can actually be categorical. If I say how healthy are you from where 1 equals poor, 2 equals fair, 3 equals good, 4 equals excellence. I just define you as having 4 different possible values with numbers that are represent 4 different categories. But what did I do? I didn't talk about stats. I talked about meaning. I talked about interpretation. I talked about what is the import of the data. And this is why you have to go back to the code books. You have to go back to the context. And with R, again, that's not always in there, right? It's just the data. So grades here is, I don't think, do we have grades here? Yeah, we have grades. Okay. So this is another issue with grades, with lacking a code book. We have grade level and you have grades. So could grades be categorical? What do you think? I don't know. I've had an average GPA. Sometimes it was really good. Sometimes it wasn't good. Averages matter. In other words, yeah, it's something you can count for any student. Yeah, you can do that. So it makes sense, but also the distance between the categories makes sense. There's the distance between 3 and 4, for example. You know, obviously it means a lot to us and in your personal life, but what I'm saying is it's structured that way, and it makes sense to represent it as something with a distribution, right? I've analyzed school data for consulting, for example, and school districts are interested in not only mean differences or average differences, but also what is the range of students who fall within, you know, above a certain threshold. So yeah, some of it goes back to theory, but also it's common sense. I'm pointing you toward the ranking because it's a little more confusing, because keep in mind that these 4 variables are not independent. Unlike every other numeric variable that we've seen, we know this is numeric because if you only have 4 slots in the survey. This is why it's also useful to look at the survey and what is actually being done. It's rare for statisticians like me to even fill out a survey, but it's so useful. You have 4 boxes. You can only pick one. Okay, where are you going to put the 1? Where are you going to put the 2? Where are you going to put the 3? Where are you going to put the 4? You cannot assign looks a 4 everywhere. You have 4 numbers that belong in 4 different places, and what that means then is that these values are not these columns are not independent. What does that mean? Well, in the sense that if I know that, let's take this first person, this 10-year-old girl has assigned her priority to money, then to looks, then to sports, I know for a fact that what she's going to assign to grades, because there are no degrees of freedom. She's already picked her choice. So this is an instance where looking at context really matters, because the variables themselves are not independent. You have to look at them in relation to each other. So does that make sense? I hope. Right. So in this case, the ranking makes sense because they're not individual. If for example you said from 1 to 4, with 4 being awesome and 1 being not awesome, how much do you like each attribute? Then you could probably assume that they're categorical variables. They're technically called Likert items, right? It would be a categorical response, kind of like that health variable I gave as an example, for 4 kinds of opinions with 4 discrete categories. But that's not the case here. And the reason we know this is because of the context. Does that make sense? I hope I didn't belabor that, but it's a little unusual and it's an easy mistake to make. Okay. Any other questions about numeric variables? So we can also define some variables as categorical. So if we want to say, right, this is part of data management. Let's say we're concerned about A students and then the rest. Okay, then we can create a categorical variable. That's easy to do. If we want to, we can do this with age. I talked about this last week. Let's say we want to separate the Titanic passengers into minors and adults. Okay, I just created a categorical variable from a numeric variable. So yeah, you can splice and dice numeric data. The cost is you're losing information, but maybe there's a benefit there, which is interpretation, simplicity, interpretability, innovation. So these are the many 10,000 decisions you have to make. Okay, keeping on with this, we can look at the median now. Simple as before. I'm assuming we have a tilde here. And we just run this. And now we have a 2. Why don't we have to round this thing? Why is it just a 2? And I'm sorry, we're going to go a little bit longer. I'm going to put 15 more minutes in, and I apologize for going longer. Apparently, it's my fault, but please be forgiving and assume it's because of my unbridled enthusiasm for the class and for helping. Why do we have a number here? What happened to our decimal places? Oh, absolutely. Yeah, I'm posting it tonight, especially now that the internet works. So definitely will. So why do we have a whole number when we have medians? In fact, why don't we just figure it out? What you can answer the question here just by looking at this natively, but I'm going to give you a little more context here. Why do we have whole numbers here? As opposed to when we run the means, we don't. Well, we don't often have the average, but that's the case of, so the median is the central value. In other words, it's more often the case the value that actually exists in the data sets. So this is an interesting distinction. There's no average in reality. That's where we go into statistical models. And model is an important word to remember. A model is, if you ever built model airplanes, if you were to look around, I'm obsessed with maps, right? This is one of my things. Why? Because a map is a representation of something. It is not the thing of itself. Do not confuse the map with the territory. Well, in statistics, we have models. They're approximations. No student is 2 points, whatever it was, to so many decimal places. But there are students who are reporting 2s and 3s. So the median gives you the middle value. Now, if there's a tie for the 2 middle values, say, then you will do the average of those 2, so it'll be the midpoints. But in large data sets, that often doesn't happen. So the median is simply the middle value, and it's something that actually exists because you can just, if you just line up all the values, it's like lining up all the height of kids in the classroom, and then you pick the one in the middle. That kid actually exists in the real world, as opposed to taking all the kids in the classroom and then taking the average of their heights. Well, the average heights, it's the joke about Americans have 1.7 kids and 2.3 dogs. There are a lot of stats jokes about that. Yes, and it depends on, you're not going to get the same answer here. Because keep in mind, central tendency is an attribute that varies according to response. So if it is the case, because we have 4 values, if it's the case everyone reported identically to each of the 4 responses, they just said, oh, screw it, I'm just going to respond randomly, then yeah, we'll have the same answer here. But that's not the case. And I think it's clear when we start off with the averages. So I'll rerun with the averages here, or the means. But the point is a central tendency shifts. It's a variable. Variables tell us how the data vary. So that's why we have different values of medians, because sometimes the central tendency shifts enough that we're not picking a midpoint, we're picking 3. And so what do we find? Well, does that make sense? I hope. So the point I want to make is medians are more robust to outliers, by the way, right? Because they actually exist in the data, and they're the middle value. You pick it out. And averages are essentially derived from adding everything up and dividing by the number of cases, subtracting degrees of freedom. And that can be skewed if you have outliers. I didn't even mention that, but that was from lecture. So that's why Bill Gates is really screwing up Harvard dropout salaries, right? He's famous for being a Harvard dropout. Zuckerberg as well, right? I'm not sure that's a case to drop out of Harvard, but take those two values out and we'll see what the average is. That's more meaningful. Or take the median. So that's important. That'll be on the exam. That's a really good question about the median, though. So the median is a little bit maybe less informative in a way, because especially with a small data set with few values, it just kind of shifts around between 2 and 3. But it gives us a better idea of what's existing in the data and it's robust to extreme outliers. So what do we know? Well, apparently the kids like looks and sports more than grades and money. Okay, that's what we're finding here. To be popular. That might make sense. I don't know. I think, and there are probably other options as well. Should I belabor the point? Yeah, I'll do the average here. So all I'm doing is I'm switching. So this is a great example of, if you look at the repetition of the code here, this is where I really would like to do some sort of looping or some sort of shorten this code, because there's a joke that programmers are actually really lazy. They aren't. They're the hardest working people I've ever met. But we don't really like to type things over and over again, because that's when we have mistakes. But I'm going to show you what the means look like, and then we can compare that to these medians, right? So we'll just run this. You have a little bit more information, right? So instead of having a 2, a 3, 2, and a 3, now you have a 2.1 and a 2.6 and a 2.08 and a 3.2. So you can sort of see, well, really, if you take the average, the least valued is money, followed by grades, followed by looks, followed by sports. So you want to be popular in school, go to be an athlete. Okay, that's what their kids are telling us. But having good looks is apparently pretty much up there. Okay, so that's of course not reality. It's the perception of reality, which is also important. Does that clarify more than obfuscate, I hope? Okay. All right, great. Great, thank you. I appreciate the feedback, even if it's just a short yes, because I want to do my job. Okay, so now we have age. This is 99% of my life. I'm doing age. I'm putting age in so many stat models. So it's less convoluted than ranking. All right, well, here we have the median age, and then we have the average age. Okay, what does that discrepancy suggest? I kind of prefaced the answer, didn't I? Right, if you look at the Harvard dropout here. Well, we know that average is more sensitive to outliers, right? We're talking about central tendency. Where does most of the junk lie? And then dispersion, what's the spread? Well, if we have a central tendency and we have an average, it can be pulled upward. Yeah, I feel like I'm maybe doing stage right, or pulled downward. Well, what's happening here? Well, then we know that the median is more robust, so it's going to be pretty rock steady, right? Sort of like hurricane weatherproof. It's not going to be. It's going to stand there. It's like that southernmost point in the shed in the Florida Keys. It's going to stay there, so we can kind of count on it as a somewhat of a benchmark of central tendency. Caveats aside, of course, like in any case. But we want to compare it to the average. Well, the average is getting lower. What's going on? Oh, it's getting pulled down. What's dragging it down? There are more kids who are younger in the age distribution. Right? This is the opposite of the Bill Gates effect. If this were like salaries of Harvard College dropouts, you would actually see 2 people with a huge amount of money pulling the distribution, the average way out of bounds. And this is why averages are misleading. So I'll tell you even a stats joke. I don't even care. A statistician is the kind of person who puts his hand on the stovetop and puts his the hot stovetop and puts his other hand in the freezer and says, on average, he's feeling okay. His hands are pretty normal. Stupid joke, I know, but it's, if anything, it's a caveat to all of us. Like, yeah, averages. I want to see what I want to more often than not. I actually want to see the data. Now, speaking of a measure, moving from central tendency, we're going to go to spread. How do we spread this sucker out? Thank you for the haha, by the way. I have plenty of other bad stats jokes if you want those, but that's later. Okay. Standard deviation and variance. What's the big diff here? Think of the word standard, standardized test. What's the point of a standardized test? Well, technically, ideologically, it's to compare apples and oranges. We all know that we're all unique snowflakes, and I don't mean to use snowflakes in the pejorative sense. I mean, we're all unique, wonderful individual people with creative capacities. But we are also beholden to a society that will submit us to standardized tests. Sorry, this is part of education. You're going to get the same test. You're not going to get the identical test, but you get the same homeworks. Standardization simply means we want to find a way to compare different kinds of metrics, right? We have different variables with different values. Maybe we have ages and then we have money. Okay, I still want to compare the spread of those two for whatever reason, even though the values of those variables are different. The standard deviation tells you the spread by standardizing by the value of it, of the number, of the variable. So there's a better way to explain it. Think about it in terms of currency. Let's say you want to see what's the average spread of wealth, of income in the United States, where we have dollars, as opposed to Canada, where they have a Canadian dollar, the loonie, I think they call it. It's different. So we can't exactly just look at the raw numbers here. We have to standardize by what the value of each currency, of what each unit is. So in many cases, that permits us to do comparative research. One standard deviation is the average. On average, how far are you from the central tendency? So most people will lie within 2 standard deviations of the mean, right here, right? So there you go. Any other questions about the standard deviation? I think it's an interesting concept. It's in some ways, as a sociologist, it's a way of creating and homogenizing populations that maybe aren't exactly homogeneous in reality, right? It started off in France, where they really wanted to have one French Republic. Quetelet was a famous statistician, talked about the homme moyen, the average person. This is a concept that didn't exist forever. You know, it's something that came up in modern society. This is really pretty recent stuff. Variance? Yeah, okay, we know what variance is. It's something that varies. Problem is, there's no context there. We don't even know what it really means. It's not standardized, right? It's sort of like if we took out standardized tests and we just decided to give stars to some people, check marks to other people, and then A, B, and C to other people. It just doesn't make any sense, right? So it's it can hamper communication. But keep in mind that they're related, right? So variance is related to standard deviation. That's covered in lecture, but that's how you do it. Again, it's pretty intuitive. Use the tilde always. Okay, box and whiskers plot or a box plot. This is just a measure of distribution. I'm going to go pretty quickly through this just because I know time is getting pretty far gone. A box and whiskers plot basically illustrates central tendency and distribution. It's best for looking at outliers. If you can squint, this is like a constellation. Maybe that looks like a cat with whiskers. Those little things out on the side. I don't know. There's a box. The main point is that little black dot there. This right here, it's right on 11. Well, what's 11? That's the median. It's robust. Then you have the interquartile range, which is basically splitting it up into fourths. And then you have these whiskers, which I believe are 1.5 times the interquartile range. Not that relevant here. Again, here I am going to go against precision. We don't care what precise value this has or what precise value this has as long as the inputs are correct, because we're looking at the big picture here. This is the utility of figures. It's also the utility of communicating your research. If you're going to talk to your boss, they're not going to care about 10 digits. They want to see what the data look like. And what we find is there are 2 outliers here. And if one whisker is longer, then maybe that's kind of skewing it a little bit more here. And this outlier here is really far down. So that's skewing that age a little bit lower. Here are other ways of exploring rows in the data set and also creating smaller sample sizes. Don't worry about it. I think it's not relevant, but I think the most important thing that we'll leave on is my favorite function in Mosaic. It's called favstats. Okay, what's going on here? Well, look at this. We don't have a tilde. So I will check the website. Has anyone checked the code on the website to make sure that the tildes are there? I'm hoping that I just actually, because I wrote the code, I had an earlier version. If I made any error, I really am sorry about that. Otherwise, we can just blame the people who developed it. Okay, favstats is great because it's, we often talk about what is a 5-number summary of the data. This is a good numerical snapshot. You want to know what's going on. Here we have the minimum, lowest value, the maximum, highest value. We have the median, we talked about that. We talked about the mean, standard deviation. We never talked about the n. N is just number. What's your n? Okay, how many people, how many rows are there? The Q1 and the Q3, that refers to the quartile ranges. Just keep in mind, what does the median do? You're cutting the sample into 50-50. Those above, let's go to, use the height example. I'm sensitive to that because okay, thank you for the response about the homework. I'm 6'4", so embarrassingly, I was pointed out in my stats class in grad school as being an outlier. Okay, well, great. Well, where am I? I'm on the upper half of the distribution. If we lined up everyone in my grad class and we split them up into 2 groups, you'd have those above the average height, so above the middle person. We line everybody up, we'd find the middle person, and then the taller half goes on one side, the shorter half goes on the other side. I would be in the taller half. I'd even be an outlier. Then you would take each of those halves and divide those into 2 groups. And just think about a dollar bill. You're dividing it up into quarters. The key distinction here is that you're starting with the middle value and dividing it from there. So it's still a measure of dispersion if you look at the interquartile range. In other words, if you look at the distance between those who are in the top 25, top quartile of the group versus everyone below that. If you look at, quartiles are not that often used. I'm sorry, I'm not being clear here. If we take the median and then we have the lower quartile and the upper quartile, we can sort of say that's akin to standard deviation, right? We can talk about above or below the standard deviation. It's just a different way of representing it that's a little bit more robust. It's less common, but it is still a way of looking at dispersion, even though those are indicated as separate numbers. So when I look at the Q1 and the Q3, I look at where on where not on average, where do most of the kids lie? Most kids are responding between 2 and 4, right? And 4 is the maximum. And that's actually a problem for the data set. So I was in the class and I was certainly not even in that middle part of the quartile. I was an outlier. I was probably skewing the height of the students there. So, and I'm sorry for using the English system for those of you who are used to the metric system, which we should use. It's much longer than before. This is my duty to just show you that really fundamentally, before looking at numbers, I'm a visual person. You kind of want to look at distributions. There's our age distribution. You can see where most people lie. There's our age distribution for, I think, a subsample. These are histograms, they're not bar charts. A histogram is different because the y-axis here is a proportional representation of the relative density. Don't worry about it. The main point is squint your eyes, don't worry about the numbers, and look at the shape. Where does most of the stuff lie? Again, this is the beauty of graphics. It gives you a good bird's eye view of what's really going on without having to, dwell on the numbers, because you can get lost in the forest. So yeah, that's about it there. I do have a video on box plots and other graphics that I think will explain it in a little bit more detail. But for me personally, this is why I love figures, and this goes back to my critique of false quantification, especially when we're talking about averages. We don't need to know to 7 decimal places. We might want to know your code to make sure that it's replicable, but when we present data and we communicate it, let's be human here, okay? I often don't even know where I left my keys, so I'm not going to remember 6 decimal places, especially the more important the person is, right? Okay, any other questions about numeric variables? I feel like we did go longer, but I hope it was worth it. I'll post this tonight. As soon as this is over, it'll take a while to load. Okay, thank you. Okay, great. One critique has been, I've heard that this is just my personality. Maybe I'm a little rambling a little bit. That's why I put it on YouTube. And that's also why I tend to keep sections shorter. But if you are want to speed it up, make sure you play it double, triple speed on YouTube, and it's a piece of cake. Or just skip ahead. Okay, have a good night, everyone. Good luck, and keep in touch. I gave you my contact info. Have a good night. Bye-bye.